Let's talk more about alignments and pairing and a little bit about the result manager. Let's go ahead and say import. Choose a measured and reference data set. The measured data set goes into the measured folder. The reference data set goes into the reference folder, just as before. Now we have a new alignment type called initial alignment, which is a quick best fit. Once this gets us very close, we can choose from any of the other alignment types in order to refine our alignment. Let's go ahead and choose a datum alignment in this case. I'll turn off the visibility of my measured data set. And I'll click a couple datum features. Press OK. Now, as soon as we do our first feature-based thing, or first feature-based operation, we generate something called a pairing map. And a pairing map is very similar to correspondence. Pairing map defines the relationship between our reference data set and our measured data set. We can edit it by double-clicking on it or editing it from the Tools tab. We can assign global or local pairing preferences. What these do are define pairing parameters for the entire shape or just for a single face. Let's choose global pairing. In this case, maybe I have a rule where I roll back from the edges 0.2 millimeters every time. I'm going to choose the lock button, just like in Design X, to keep this feature persistent. Now go ahead and choose OK. When it's done calculating, we can see visually on the screen what our pair points are. You can also visually see the fact that we will, in fact, roll back from the edge the required amount. Now, if I specifically want to change pairing parameters for a specific face, I can choose the local option. Then choose one or many faces. And then I can say, all right, maybe I want to do a 50% sampling ratio as a rule, or 2 sigma allowance for data. And I'll go ahead and choose accept again. All right, you can see that the data has been accepted. Let's move back to global, and you can confirm the fact that we're mixing both locally defined pairing parameters and globally defined pairing parameters. So anytime I use any face in the measurement, we will always use the paired points that are indicated. Moving on, I'll turn off the lock and I'll say OK. Now you can see a rebuild sign here. Since we have affected faces that were used in the datum alignment, we're going to want to redo our datum alignment or recalculate it. The software will do this automatically. Next thing we want to do is add an inspection feature. I'll go to Home and choose 3D Compare. I'll move to my next step. And you can see that I've automatically asked the software to pull out the highest over tolerance feature, and it's indicated right here. So let's go ahead and change our color bar down to something like 0.25 millimeters. And now I'll go ahead and choose a couple areas of interest for me. All right, I'm going to check yes. The next thing I want to do is show you a little bit about the multiple results system and comparing between results. I'm going to go ahead and right click on my result and choose to rename it. We'll call it tuning peg datum alignment and press OK. I'm going to go ahead and duplicate it. Now this just makes a copy of this inspection project. You can see I've got tuning peg with datum alignment, and I have this blank result too. It was just copied from my datum alignment result. I'm going to right click and choose to rename it. I'm going to call it tuning peg best fit alignment. I'll say OK. Apply my best fit alignment. We'll go ahead and choose best fit. And we have an option called use selected data only. This allows us to use only the faces that I select in the calculation of the best fit. So I'm going to do something similar to my datum alignment, but except I'm going to choose this entire cone of faces, or this entire axis of faces, and then the other faces. Let's choose these guys too. I'll press accept. Now it's telling me that some of these features will need to be rebuilt. So that means that based on the new alignment, I'm going to have to recalculate my deviations. We'll say OK. All right, let's take a look at our values here. You can clearly see that the results of our deviation analysis are totally different between best fit and datum alignment. Now, how can we look at these both at the same time? The first thing I want to do is go to Tools and choose Result Navigator. Result Navigator is going to show us graphically at the same time both of the results. So if I turn this around, you can see visually that clearly the results are different based on our alignment techniques. And also, you can appreciate the text values. Let's find the value for the top of our sphere. So here, with a datum alignment, which is indicated by tuning peg datum alignment, this deviation is 287 microns. And with tuning peg best fit alignment, it's 229. We could do this with multiple inspection scenarios in one data set, or one inspection scenario and many data sets to see how a part performed that was made yesterday and today.